Welcome to part one of Competency 16. In Competency 16, teachers need to understand concepts and applications probability. This competency is part of Domain 4, which is 14% of your examination. In this video, we will work with basic probability, permutations, and combinations. If you haven't already, please familiarize yourself with the basic probability of an ordinary number cube, aka dice, and also for a deck of playing cards. Note that there can be a lot of questions asked because of the different types of cards in a standard deck of cards. The notation is P of A, and that is also the desired outcomes over the total outcomes. The total outcomes for one die is 6. Of course, for a deck of cards is 52. As we work through problems, you will see that permutations and combinations have a quick access on the TI-84. Number 1, what is the complete sample space created by an experiment rolling an ordinary number cube once? Well, that's pretty basic, and that is the fact that an ordinary number cube, which is just a die or dice, that would be 1 through 6. So our sample space is B 1 through 6. Looks like in these other examples, like D, this is including a negative. This would be a sample space for completely different situations. So that doesn't, or rather, it would be a list for something else. It doesn't apply, obviously, to die. And then 0 to 5, well, we're talking about what we actually see on the die, what is printed on each face. So 0 isn't printed on an ordinary number cube. Now, a specialized number cube. Yes, it could be 0 to 5, but in this case, the word ordinary tells us what we want. Okay, so that wouldn't apply. And then, of course, A, it has 7 with 0, so no, that wouldn't apply. So obviously, the answer would be B. Okay, so then let's look at number 2. Let's move on. Okay. Number 2 says a 5-sided figure is numbered 1 to 5. Now they're telling us what it is, how many faces it has, and that is 1 to 5. So we're not going to have 6 choices, okay, on each side of the face. If the figure is rolled twice, how many outcomes are in the sample space? Notice they're not asking for probability. We're not worried about that yet. We're just saying, okay, how many outcomes? Well, what outcomes do you have? This is what we have. We have 5 possibilities, and we're only looking at it twice. Therefore, that's 5 to the second power, which equals 25. Or you could just stick that in your calculator. If the number was kind of strange, say it wasn't 5, they said you've got some list from 1 to 99 and you select from it, here's your probability. If they created this situation with a larger number, well, we know 5 times 5 is 25. But let's say we didn't know. We'll pop that into your calculator, okay? And then if it, let's say they said 3 times, okay, you have this 5-sided and you want 3 times. Well, then you would say 5 carry up 3, and there you go. You can always use your carried up as the uh, degrees get larger. Use your exponents, that is. Okay, now the next items look like they're going to use permutations. Okay, now let's look at that before we move on. Okay, well, what does this mean? For one, we can use our calculator. Okay, and N is the total number of outcomes, and R is the required or desired. So let's move on to number 3 and see how to use that. Number 3, an experiment requires drawing 3 cards from an average deck of 52 playing cards. If the cards are drawn without replacement, how many outcomes are in its sample space? This is a permutation. How do I know it's a permutation? That is because the order will matter. Okay. Once we draw a card, we will not draw it again. In a deck of cards, each card is unique. Okay. And it says without replacement. So we aren't talking about someone just holding the cards in their hands where they can shuffle it. We're drawing it, it's coming out of the deck, it is unique. Therefore, the order matters. The fact that it's unique matters. Okay, so this is a permutation. So what do I do? Not bad. First, we note that we have 52. And we note that we are taking out 3. All right. So push alpha window, and a permutation is number 7. So push 7. So we have 52, arrow over. How many am I pulling out and not replacing? That is 3 cards. Push enter. And that would be option B. Okay. 132,600. There you go. All right. Now, let's look at the difference in a combination. Now, we go to a combination in the calculator the exact same way, except we're going to select number 8. Okay. So this is when the order doesn't matter. Yes, they might be unique, but I can shuffle them around and I have just the same combination. Okay. So number 4 says, in a game of cards, a player is given a hand of 5 cards. So we're talking 5. Okay. And they should have said ordinary playing cards, but we can make that assumption. How many different hands are possible? Okay. So how many different combinations as each person holds it in their hand? So the order of the 5 cards isn't an issue. So what do? We do the same thing on our calculator. You say alpha window, but we need number 8. We still have 52 cards, but this time we're talking about 5 cards being pulled out. Okay, so take the 5, push enter, and that is, looks like selection D. Okay, the others are pretty large amounts, but it could have been true. Also, it could have been the difference between the combination and the permutation. Just remember that your combination is where it doesn't matter. Order doesn't matter. You are talking about, oh well, this is my probability of this little set I want. This is what I desire, but it doesn't matter how you give them to me. I just want that many. Okay. All right. This is the last question in this first video of Competency 16. We want to make it short to introduce the concepts. And throughout the next videos in this competency, we'll use these features on the calculator. All right. And once again, thanks for watching, and thank you to everybody who's subscribing and liking and sharing our channel. And we look forward to seeing you in the future. Happy testing, everybody.